So now we want to talk about the gradient or the slope of a line. And we usually use a common M to represent gradient of a line. And what is gradient of a line? The gradient, or sometimes we call it the slope of a line, it represents both the steepness and the direction of the line. It is a ratio of change in y and the change in x as shown in the formula below. Now if you look at the formula below, M, we have rise over run, and we'll discuss what that is later, rise over run, and the most commonly used one, y2 minus y1 over x2 minus x1. So it's a ratio, change in y and the change in x. So y2 minus y1 represents what we call the change in y. Alright, it's the difference in the y values, and x2 minus x1 represent the difference in the x values. Alright. Now here we have a question. We have a diagram below, and we're asked to determine the gradient of this line. Now if you look at the line, let's put this line here. Notice, so we have 2 points, known points here. So we have -4, -1, and we have 2 and -5. So as I said in the previous videos, we were doing length and midpoint and so on. It's up to you to determine which one is x1 and which one is y1, and likewise x2 and y2. It's up to you. So remember, the first value is the x value, the second is the y value. Let me call the first value here x1. So this would be y1. And let me call this value x2 then. And this one would be y2. So if I'm using this formula to calculate the gradient, I would have m, let me just rewrite it, y2 minus y1 over x2 minus x1. So we'll end up with, let's do this up, the y2 using, what's that, -5? Yes, that's 2 minus 5 is the point, right? So we're using -5 for y2, so we have -5 up here. Minus, and what is y1? y1 is -1. And x2 is 2 minus x1, which is -4. So this becomes -5. Double negative here give us a +1. And the double negative here give us a 2, was 2 plus 4, right? And I know a lot of persons think it's strange that the double negative give a positive, but it's the same in English grammar. If someone says a task is not, someone say a task is not impossible, what are they saying? It is possible. The not and the im is a prefix for not also. So the not and the im make it possible. So if something is not impossible, it means it's possible, right? Or someone say they're not unhappy. Alright, the not and the and mean they are in essence they are saying they are happy, right? So it's the same in English grammar. So don't think it's maths only. So we continue. So -5 plus 4, -5 plus 1, that's what? That's -4. That's -4, right? And 2 plus 4, that's 6. And of course, this fraction -4 over 6 can be reduced to -2/3. Alright? -2/3. We soon discuss what it means when we have a negative gradient versus a positive gradient. Let's do another example. Before we go to the other example, I just realized I wanted to use a rise over run and see if we get the same 2/3, -2/3. Now, The run, let me put the run at the bottom here. So the run is really the base of the triangle here. So you're moving from -4 to 2. So from a -4 to here, the distance is 4. And then from here to here, the distance is 2. So that's 6, right? So again, from here to here, realize that from -4 to here, so that's a distance of 4. And then 2 more, so that's 6. And then the rise, you're rising from -5 to -1. Alright? If you want to count them. So the rise is, well, here's the thing about it now. We will not use +4 and we use a -4, and here's the reason why. As the graph moves from left to right, it is falling. So we say it has a negative rise. Right? Versus, let me show you a graph that has a positive rise. Let's just make the distinguish between the two. So suppose a graph had a slope like that. We say that it has a positive rise, and these type of lines will have what we call a positive gradient. I would say a positive slope, because as you're moving from left to right, the line is rising. This graph, as you're moving from left to this line, as you're moving from left to right, the line is falling. So this graph will have what we call a negative rise, while this one on the other hand have what we call a positive rise. So even though the height of this triangle here is 4, we're using -4. Good? Alright, so and then we'll get the same -2/3. Alright, so whichever formula you use, you get a -2/3. Let's look up some more examples in other videos.